Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the mobility of the hydrated ion. In the previous lecture, we have learned about the radius of the hydrated ion. On screen, I have taken an example of group 1 element, that Li positive. Now, Li positive is surrounded by the water molecules. In a water molecule, we are having the delta negative charge on the oxygen atom, and that delta negative oxygen atom is making an interactive force with Li positive. So more number of water molecules will surround Li positive due to the high charge density of Li positive. So more hydration will take place. That means the Li positive is having a very high extent of hydration due to the high charge density. Now more number of water molecules will surround the Li positive, so a bigger ion will form with a high radius, with a larger radius. Now if more water molecules are surrounding the Li positive ion, that means the more heavier hydrated ion it is forming. So the more heavier hydrated ion will have the lesser mobility in the solution. So let me write this thing first for you. I'm writing more the extent of hydration, more the extent of hydration of any ion, then more number of water molecules, more number of water molecules will surround that ion. So what's gonna happen? We are going to have the hydrated ion with a larger radius. So hydrated ion will be formed with larger radius. So which means that we are going to have heavier hydrated ion. We are going to have heavier hydrated ion. This whole assembly is called hydrated ion. Let me mark a boundary for the hydrated ion. So this whole assembly is the hydrated ion. It's a spherical in shape. I have made in a 2 dimensions, but it is actually in 3 dimensions. That means this whole hydrated ion is in a spherical shape. So heavier hydrated ion will form, which signifies that its mobility will decrease due to the heavier nature. That means I'm writing mobility of hydrated ion will decrease due to the heavier nature. So now let's talk about the trend of the mobility of hydrated ion down the group in a product table. I'm taking the example of group number 1. Let's talk about group number 1. The group number 1 ions are lithium positive, sodium, potassium, rubidium, cesium, francium. Now in the previous lecture, what we have read? In the previous lecture we have read that down the group the extent of hydration decrease. Down the group, the extent of hydration decrease. Why so? Because down the group, the charge density of any ion decrease due to the increase in radius, and the hydration energy is inversely proportional to the radius of particular ion. Now, when we are moving down the group, the radius of cation increase, due to which the magnitude of hydration energy decrease, which signifies that down the group extent of hydration decrease. Now, down the group, extent of hydration is decreasing, hydration energy is decreasing, which means that down the group, lighter hydrated ion will be formed. Lighter hydrated ion will be formed because down the group extent of hydration is decreasing, due to which the lesser water molecule will surround the cation, and hence the hydrated ion will be formed with a lesser radius and the lighter hydrated ion will be formed, which further signifies that mobility of hydrated ion increase down the group. Mobility of hydrated ion increase down the group due to the decrease in the extent of hydration down the group. Now, let's come to the Li positive. The Li positive is maximum hydrated in the group number 1, maximum hydrated in group number 1 due to the highest charge density, due to which the radius of hydrated ion will be large. Radius of hydrated ion will be large and hence will have less mobility, because hydrated ion will be very heavy. On the other hand, now let's talk about the French positive. It is minimum hydrated. It is minimum hydrated, due to which radius of hydrated ion will be less, and hence lighter will be the hydrated ion, so mobility will be more, or you can say mobility will be high due to the less extent of hydration. The mobility of hydrated ion will be high due to the less extent of hydration. So that's all for today. I hope you all got today's lecture. It says that more the extent of hydration, more heavier the hydrated ion will be, and hence less the mobility of the hydrated ion. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.